looking at Chapter 5, Lesson 1. So, Chapter 5 gets into trig identities. Some of these are going to look familiar. Some of them are going to look completely foreign to you because we haven't talked about them a whole lot. So, as far as what you're kind of doing is basically trying to use your identities to actually prove that something is true. Kind of like in geometry when you had to prove that a triangle was a triangle, except for there are specific identities that we're going to use. We are only doing lesson 1 and 2 in this chapter, and then you're done. So, you will not use them a whole bunch. So, looking at this page in your notes, there are several identities listed. You should be getting an orange piece of paper today that has all of the trig identities, and then as well as the law of sine or cosine, maybe both of them, I don't remember what I put on it, where you will be able to use your orange paper on a quiz with this, or if you're taking your final, you'll want it for your final, but also to help with homework instead of having to flip through your notes. So your first set of identities that you have are these reciprocal identities. So some of these should look familiar to you. So basically that sine and cosecant are opposite of each other, cosine and secant are opposite of each other, tangent and cotangent are opposite of each other. So reciprocal meaning it's just 1 over kind of their opposite. Your next ones are quotient identities. So quotient identities are only going to be tangent and cotangent because those are the only ones that are actually dividing something. So if you remember back to your unit circle, your cosine value is your x, your sine value is your y, where your tangent value was y divided by x, or sine over cosine, and then cotangent would just be the opposite of that. Your Pythagorean theorem identities are, I think Pythagorean theorem is a squared plus b squared equals c squared, which is kind of where these come from. So taking your y value, squaring it, plus your x value and squaring it is equal to 1, so on and so forth. For these, and you can add these to your orange paper, there are other ways to kind of write them. So what I mean by that is you may not always see sine plus cosine equals 1, or specifically sine squared plus cosine squared equals 1. You may see it to where it's sine squared is equal to 1 minus cosine squared, or you may also see cosine squared is equal to 1 minus sine squared. So kind of just a different format of writing that. Same thing with the other ones. So for your next one, the tan squared plus 1 equals secant squared, you may see this as 1 is equal to secant squared minus tangent squared. You could also see it written where tangent is by itself, and then you have secant squared minus 1. So knowing that these are not always going to be necessarily given to you the way that they are stated, but they could be rearranged. So for this one, you might have 1 equals cosecant squared minus cotangent squared, or you might also have that cotangent squared is equal to secant squared minus 1. So for every Pythagorean theorem identity, there's kind of 2 other options of how it could also be written, so you may see those as well. Okay. So getting into what this kind of looks like, and how you're kind of going to use these is going to depend on what you're given, what the question's actually asking you to do. So for this first one, so for example 1, these are using reciprocal and quotient identities. So for your very first one, it says cosine is equal to 3/4 and asks you to find cosecant. So going and kind of looking at your orange paper if you have it, or kind of scrolling back up and looking at your reciprocal identities, I see that cosine is equal to 1 over secant. So I'm going to write that. Oh, not secant squared. So where this comes from, and to kind of explain, I know that cosine is 3/4. So for this question, secant is your reciprocal. So kind of using that identity, you would actually have 1 over secant. With reciprocals, we generally just flip things around, which is ultimately what we are going to do. But the process of getting there would look like, I know that it would be 1 over 3/4. If I have a fraction divided by a fraction, ultimately I am multiplying by the reciprocal, which is just going to end up leaving me with 4/3. Is kind of where that comes from. So that is secant. On that one, it's also really just the reciprocal of it. It's not anything more complicated than that. Sometimes these are going to ask you to use the identities, so you actually have to identify which identity you would potentially be using. So looking at your second example, this one gives you 2 pieces of information because you need both pieces of information to kind of find what is being asked of you. So it gives you that secant is 5/4 and tangent is 3/4 and is asking you to specifically find sine for this question. Thinking through what these identities look like. Secant is the reciprocal of cosine. I'm not trying to find cosine, I'm trying to find sine, so that's not really going to help me a ton. However, with my quotient identities, I know that tangent is sine over cosine. So where that is going to help me is kind of plugging this in with your missing pieces. However, there is a reason you are given secant. So earlier I said that secant is the reciprocal of cosine. So this cosine kind of at the bottom, instead of leaving it as cosine, I'm going to change it to a reciprocal identity, which is where the secant is going to come in. So I'm actually going to write this as sine x over 1 over secant x. So that's where that is coming from. For this, you're now kind of plugging things in. So I have that this is equal to tangent x. So tangent, I know, is 3/4, so I'm going to plug that in here. Sine is what I'm trying to find. Secant is given to me in the problem of the 5/4, so I would write this as 1 over 5/4. Sorry, running out of space. It's kind of how your problem is going to be set up. So to solve from here, I'm going to end up multiplying by the reciprocal just on this bottom part to get this kind of away, and then I'll explain from there. So I'm going to work this way. So I'm not necessarily multiplying with the sign right now. I'm just trying to get this fraction and a fraction to go away because I really have like 3 fractions within themselves. So I'm going to multiply by the reciprocal of 4/5. So when I do that, I'll end up with sine x over 4/5 is equal to 3/4. So I kind of just dealt with my bottom fraction for a second, and then I'll worry about my other fraction in a minute. Okay. From here, I need sine by itself. This is kind of weird because we normally, like, if it's division, talk about moving it over and multiplying by the reciprocal. However, if I need sine by itself, this is a division problem, so I'm multiplying, like just multiplying, not multiplying by the reciprocal. Since it's not dividing, I'm just multiplying it over. So I'm going to multiply it over, and when I do that, remember when you're multiplying fractions, I'm multiplying numerators and then multiplying denominators. So I would end up with sine x is equal to 12 over 20. If you can simplify them, simplify them. We know both of those are divisible by 4, so I would be able to simplify this further to 3/5. Okay. So again, plugging in to your identities, knowing what is going to help you get to your final answer. Secant and tangent on themselves don't give me a sign, so I would need to be able to change them to be able to give me a sign and then have other things kind of cancel out as I'm working. All right, looking at this next one, if you want to attempt it, you are more than welcome to do so. You would kind of have to find your missing side measure. So what I mean by that is secant is only going to give you secant is the reciprocal of cosine. I'm being asked to find sine in this question, so you would have to use your Pythagorean theorem, like just normal Pythagorean theorem, a squared plus b squared equals c squared, to find your missing piece on this type of question before you actually figured out what your sine value is. There are other ways to go about it. However, kind of one of the easier ways. If you want to solve this question on your own and figure it out, you're more than welcome to. To give you the answer to this one, if you wanted to work it out, the correct answer choice is B if you want to go back and work it out. So looking at example 2, example 2 gets into the Pythagorean theorem identities. So again, those ones that we kind of rearranged as far as there are other ways that you may see them as you are working through these questions. So example 2 says if cotangent theta is equal to 2 and cosine is specifically less than 0, there's parts of that matters, and we'll talk about it once we get to the end. It is asking you to find cosine and also sine values. So you're finding 2 things in this question. So as kind of a starting point, thinking about cotangent and your Pythagorean theorem identities. And again, if you have that piece of paper, use it to help you. So cotangent is going to be this last Pythagorean theorem identity that says cotangent squared plus 1 is equal to secant squared. So that's the one that we're going to be looking at. I know that because I'm given cotangent. That's why I'm picking to use that one. So I'm going to write this, just my identity out, so we have it to start with. So from here, you are told what cotangent is. So I'm told that cotangent is 2. So I'm going to replace the value of cotangent with 2 and fill that in and kind of work my way from there. So now I kind of actually have a problem that I can solve. So 2 squared is going to give me 4. I can then add those together to get 5 is equal to cosecant squared theta. Nothing in my answer, so like it's asking me to find sine and cosine. Neither one of those are squared. So remember, if I have something that is squared, to get rid of it, I'm taking the square root of both sides. When I do that, remember that you have to put your plus or minus in front of your number. So I would actually end up with plus or minus the square root of 5 is equal to cosecant. So again, kind of my starting point. From here, you are then using whatever identities you need to be able to find sine and cosine. So one of the ways that you could do that is if I have cosecant. If I have cosecant, cosecant is the reciprocal of sine. So I can write this as plus or minus the square root of 5 is equal to 1 over sine squared, or sine theta. Then from here, ultimately, I'm trying to get sine by itself. That looks a little weird in this and kind of takes multiple steps to get to, because this isn't just sine, this is 1 over sine. So in order to do that, I would have to multiply the sine on both sides. It would cancel. So now I have sine theta times plus or minus the square root of 5 equals 1. And then ultimately, if I need cosine by itself, I'm going to have to divide by that plus or minus 1. 5. Don't know why I keep saying 1. So sorry. So now I have that sine theta equals 1 over plus or minus the square root of 5. Earlier, one of the things that I mentioned was that your cosine value needs to be less than 0. If we're talking about something that is less than 0, and I know that this one is sine, but it kind of applies to both of them. I have a plus or minus square root of 5. At this point, I need to narrow it down to just actually picking one of those. But because it's talking about something that's less than 0, I'm obviously going to have to pick the one that is a negative value. So my answer for sine would be that sine is equal to 1 over the negative square root of 5. So far I have found what my sine value is. I still need to find my cosine value. So on these questions, there's not a right or wrong way to get to your answer. There are other ways that you could work these out as long as you're using the identities. So on this one, that's kind of where I would start. From here, I now need to know what cosine is. So kind of looking back to my original problem that I was given, I was just given that cotangent is equal to 2. So I'm going to use that to now set up the second part of my problem. Where I'm going to use that is cotangent is one of your quotient identities. So cotangent is specifically cosine over sine. Why I'm using that is I know sine now because I solved for sine and I'm trying to solve for cosine. I also know what cotangent is equal to because it tells me that in my problem. So the way that I'm going to write this is cotangent is equal to 2. And then my identity is that cotangent is cosine over my sine value. So this is a quotient identity. That's where that's coming from. The next thing that I'm going to do is I know my sine value, so I'm actually going to fill that in. So my sine value is what I just found as far as 1 over the negative square root of 5. So from here, again, similar to example 1, I'm trying to get cosine by itself, and I'm dividing by that sine value. To move it to the other side, I'm just multiplying, so I'm not doing the reciprocal. I'm just multiplying by 1 over the square root of 5 to both sides. So when I do that, this side would cancel. I would end up with negative 1 times 2 is just negative 2 over the square root of 5 is what my cosine value would be equal to. Okay, so that's kind of where all of that is coming from. Again, it says cosine has to be less than 0. If you had, for whatever reason, maybe down here, picked the positive sine value, you would have ended up with a positive 2 over square root of 5, which is not less than 0. And it wouldn't make your statement true specifically because it's giving you this part in your problem. So that is example 1 and example 2. We are skipping several things in your notes. As far as some of the other examples, some of them kind of use the same concept, but just work it out a little bit differently. So we are going to do example 4. Before we get into example 4, there are more identities. If you already have your orange paper, you see all of these identities. The other identities that are given to you are what are called co-function identities and then odd-even identities. These are going to come up as well. Co-function identities will be obvious when you're using them if there's a pi involved, for certain things like that. And then odd-even identities are really only going to come up if you have a negative angle measure or negative theta in this case. It's really kind of just showing you that if I have sine negative theta, that's the same thing as negative sine theta. Some of them become positive, some of them become negative, depending upon what it is. So the only two that are actually positive and stay positive are cosine and secant. Your other ones are actually going to become negative in those scenarios. Okay, so looking at example 4. Example 4 tells you to simplify by rewriting using only sine and cosine. For these questions, you have to be careful of which identities you're picking. It specifically says only using sine and cosine, which means I'm not using tangent, I'm not using cotangent, I'm not using the Pythagorean identities that have cotangent or tangent included in them. My goal is to only use sine or cosine. So this is actually now just asking you, instead of solving something, you are simplifying. I know to start with, it only has cosine and sine in it. However, there's a sine squared, and it really wants you to just end up with a sine or a cosine. So there is a way to simplify this to just end up with like literally just a one-word answer, meaning sine or cosine. So, your first step in this, I already have 1 over cosine, so I'm going to leave that alone. My 1 minus sine squared x. If you see anything that is automatically squared, that should point you to your Pythagorean theorem identities. Those are the only identities that have squares in them. Your other ones you can kind of make have squares, but Pythagorean theorem identity is the only one that actually starts with squared included in them. So if you look back at your Pythagorean theorem identities, one of them states sine squared plus cosine squared equals 1. Again, at the very beginning, we talked about kind of rewriting those so they're written a little bit differently as far as like rearranging it. That is the one that has sine and cosine in it, which is the one that I'm going to use. One of the other ways that we wrote it was that cosine squared equals 1 minus sine squared. I have 1 minus sine squared, so I am going to change this part right here to cosine squared. So I have this, which I'm keeping, and I'm changing this to cosine squared. From here, I am now multiplying these. Remember, if you have a number, in this case, I really have a word by itself, I am not multiplying the top and the bottom. I'm just multiplying numerators and multiplying denominators. So this would end up as cosine squared x over cosine x. From this point, if I have cosine squared x divided by cosine x, they both have a cosine included in them that I can cross out, which would leave me with a cosine left in the numerator, and that is where my answer is coming from. So kind of a multi-part. I'm using Pythagorean theorem identity to simplify. I'm multiplying and I'm canceling stuff. So whenever it says to simplify by rewriting using only sine and cosine, it's asking you to just get to a literal 1 sine or 1 cosine. So looking at one more example with that, and I know it's the guided practice, but so you kind of see in a different example. Again, your goal is to only write in cosine and sine stuff. So if you're not given sine or cosine to start with, that's your goal. So like in this, I see cosecant minus cosine times cotangent. Cosecant, yes, is the reciprocal of something, but it's not actually sine or cosine. Cotangent can be written as sine and cosine. So I need to start changing stuff to sine and cosine first before I simplify stuff. Okay, so cosecant. This is one of your reciprocal identities. So cosecant is the reciprocal of sine. So I'm going to rewrite that as 1 over cosine x. My cosine value right here, I'm going to leave as cosine. It's already a cosine. I'm not messing with it. Then the last thing that I have is cotangent. This is one of your quotient identities. Cotangent is cosine over sine. If you look back at that, so I'm going to rewrite using only sine and cosine first. From here, I'm now going to simplify stuff. So the first thing that I'm going to do is, according to order of operation, I'm going to multiply stuff together. So my sine or my cosine times my sine right here, I can multiply. So I will end up with 1 over sine x minus cosine times cosine. And this is where you have to pay attention. Cosine times cosine is not going to give me 2 cosine. It's going to give me cosine squared. If that helps you think through things, okay? From here, I have a subtraction problem. They're both fractions. They have a common denominator. So instead of writing it as 2 separate things, I'm going to combine it and write it as one thing. Not squared. So, because they have like denominators, I can go ahead and combine them. Again, similar to last problem, looking at your numerator of 1 minus cosine squared x. If you see a cosine squared or anything that is squared and also happens to involve a 1, this should automatically tell you that I'm going to use a Pythagorean theorem identity to simplify. So again, it's that same one that we used in the last problem where it is originally sine squared plus cosine squared equals 1. One of the ways that we rewrote it, or you can think about rearranging it, is that sine squared is equal to 1 minus cosine squared. So I have 1 minus cosine squared. So I'm going to change the top of this to sine squared x over sine x. So kind of the same ending as the other example 4 that we just did. Now I have a sine squared x divided by a sine. They would both lose a sine, and then I'm just left with one sine in my numerator. So that is examples 1, 2, and 4. Those are all of your identities that we're going to look at. Please do not lose your orange piece of paper because there are exactly enough copies for you. And you are going to want that orange piece of paper, okay? So, tomorrow we will look at examples 5, 6, and 7, and looking at more examples that kind of use all of the trig identities. Some of them ask you to do some different things, so we will look at those tomorrow.